Hello and welcome. Today, we delve into a story that transformed not only shipbuilding but the very fabric of American industrial might during World War II. At the heart of this revolution is a simple question. How did a nation go from building ships over years to launching hundreds in mere days? Imagine a cargo ship measuring over 441 feet, built in just over 4 days. Something that defied every traditional rule of maritime construction. How was it possible for thousands of untrained workers, farmers, secretaries, housewives, to assemble a vessel in record time, replacing centuries-old riveting with welding? Could a massive shipyard in Richmond, Virginia, turn into a giant assembly line, producing a Liberty ship every 7 days? And what secrets did Henry Kaiser's bold, unconventional methods reveal about the true potential of industrial innovation? All these fragments form a puzzle. What is the real story behind this extraordinary surge in wartime production? In this video, we will trace the incredible path from skepticism to astonishing achievement, separating fact from fiction, and uncover the revolutionary techniques that reshaped global shipbuilding. Get ready. What you're about to see will challenge everything you thought you knew about industry, ingenuity, and human capability. The most remarkable chapter begins right now. On the crisp morning of November 12, in the year 1942, the bustling city of Richmond in California bore witness to a remarkable feat of industrial ingenuity. A massive cargo ship, measuring precisely 441 feet in length and weighing an astonishing 28,490,000, numbers that only hint at its immense scale, stood majestically poised at the gates of the Permanente Metals Corporation's Yard No. 2, ready to be launched into the waters of San Francisco Bay. This vessel, a symbol of rapid manufacturing progress, had been brought to life in an astonishing span of just over 4 days, 15 hours, and 29 minutes, a feat that defied the norms of traditional shipbuilding. Historically, constructing a ship of such magnitude was a process that typically spanned from half a year to nearly a year and a half, especially for vessels comparable in size, dating back to the era before the American Revolution. During those times, master shipbuilders and seasoned maritime craftsmen meticulously crafted each vessel over many months, ensuring every rivet and plank was perfectly placed. But here, in this unprecedented moment, a complete Liberty ship, an essential vessel in the wartime effort, was assembled with breathtaking speed, ready to serve its purpose in the tumult of global conflict. Surrounding this marvel were over 1,000 workers, all stepping back from the hull of the ship they had just helped to construct. Remarkably, these were not seasoned shipwrights or veteran sailors, but individuals from vastly different backgrounds, former secretaries, farmers, housewives, and laborers, people who had only recently learned welding and construction techniques just weeks prior. Their collective effort was a testament to an extraordinary shift in industrial production. The crowd of officials, journalists, and shipyard owners who had gathered to witness this milestone understood the significance of what they were witnessing. This moment marked the beginning of a profound transformation, a systematic revolution driven by American manufacturing innovation that would echo through decades to come. This revolution was not fueled by battlefield strategy or military tactics but instead by groundbreaking advancements in production efficiency and industrial methodology. The success of this rapid ship assembly challenged every assumption previously held by maritime experts regarding the limits of shipbuilding, how quickly ships could be constructed, what materials could be used, and how industry could adapt to wartime demands. The mathematics of Allied victory, it seemed, was being rewritten not in war rooms but in factories and shipyards, by numbers and production schedules that would redefine industrial possibility. The seeds of this transformation were sown on December 27, 1940, when Henry J. Kaiser signed his first shipbuilding contract. A man with no prior experience in constructing ships or managing a maritime yard, Kaiser had built his reputation in the American West through large-scale earth-moving and concrete-pouring projects, including massive dam constructions. At the age of 58, he was a construction magnate whose bold vision extended beyond traditional boundaries. Despite his background, he boldly promised the United States Maritime Commission that he would produce 30 cargo vessels for the British government within a mere 2 years, an aggressive timeline that many considered impossible. Traditional shipbuilders dismissed Kaiser as an overly optimistic outsider, a naive opportunist lacking the expertise needed for such a daunting task. The Todd Bath Iron Works, one of the oldest and most venerable shipyards in America, reluctantly agreed to partner with Kaiser, believing that their extensive experience would compensate for his supposed lack of maritime knowledge. What none of these established players could see at the time was that Kaiser's lack of conventional experience would turn out to be his greatest strength. His outsider perspective allowed him to challenge old assumptions and seek novel solutions that seasoned shipbuilders might overlook or dismiss as impractical. Among those observing with keen interest was William Francis Gibbs, a highly respected naval architect whose firm, Gibbs & Cox, had drawn up plans for the Liberty ships based on British designs. Gibbs had designed more ships than Kaiser had likely seen in his lifetime, and his skepticism about Kaiser's ambitious plans was palpable in the early days. Yet, as the months progressed, the initial doubts began to fade, giving way to curiosity and eventually admiration. The true beginning of this revolutionary journey took shape within the planning offices of Todd Shipyards in New York, where the innovative ideas that would redefine shipbuilding standards started to emerge. In early 1941, as Kaiser and his team meticulously examined traditional shipbuilding procedures, they quickly realized that adhering strictly to conventional methods would never suffice to meet the urgent needs of wartime. The demand for ships was surging at an unprecedented rate, and speed was of the essence. Kaiser's chief engineer, Clay Bedford, had recently visited a Ford Motor Company assembly plant in Detroit. There, he observed automobile chassis moving steadily along conveyor belts, with workers at each station installing prefabricated components in a continuous flow. Inspired by this highly efficient assembly line process, Bedford returned to California convinced that ships could be built in a similar fashion. However, this revolutionary idea was met with skepticism by traditional shipbuilders. They considered the comparison absurd, dismissing the notion that large ships. The initial shock wave of change swept through the maritime industry when Kaiser boldly proposed to abandon the centuries-old method of riveting entirely. For generations, constructing ships had depended heavily on the technique of riveting, a process involving heated metal pins, known as rivets, which were hammered through overlapping steel plates to securely join them together. This labor-intensive process required a skilled crew of riveters working in perfect synchronization, with the capacity to install roughly 100 rivets each day under ideal conditions. Building a single Liberty ship through traditional methods demanded around 1 million rivets, a staggering number that highlighted the enormous scale of the effort involved in wartime. Ship production. Kaiser's radical idea was to replace this tried-and-true method with electric arc welding, a technology he had gained proficiency with during his extensive pipeline construction projects spanning the American West. He believed that welding could dramatically reduce construction time and labor costs. His conviction was rooted in the fact that electric arc welding, unlike riveting, could be performed more quickly and potentially with fewer skilled workers. However, This proposal immediately sparked controversy within the maritime establishment, especially among the senior officials and engineers who valued proven techniques. Vice Admiral Emory Land, who served as the chairman of the United States Maritime Commission, scrutinized Kaiser's proposal with considerable skepticism. His private correspondence, now housed in the National Archives, vividly reveals the doubts held by many industry veterans. They questioned the reliability of welding on such a large scale, especially for critical hulls that must withstand the harsh conditions of the ocean. Historically, welding had not been accepted for shipbuilding at this level of safety and durability. Even the British Navy, known for its rigorous standards, forbade welding on its warship hulls precisely because the technology had not yet demonstrated sufficient reliability for combat vessels. Despite these reservations, Kaiser's proposal gained a foothold due to the dire circumstances facing the Allies. German U-boats and surface raiders were wreaking havoc on Allied shipping lanes with terrifying efficiency, sinking vast quantities of cargo vessels at an alarming rate. In the year of 1941 alone, approximately 3,600,000 tons of Allied merchant ships were lost to the depths of the Atlantic, destroyed by enemy action, accidents, or natural deterioration. Britain, heavily dependent on maritime trade for its survival, was on the brink of starvation, with its supply lines stretched perilously thin. Traditional American shipyards, relying on conventional construction methods, would need an average of around 230 days to complete a single cargo ship. This lengthy timeline was catastrophic in the context of the urgent need to replace lost vessels and maintain the vital supply chain. If America's shipbuilding capacity remained sluggish, it risked losing the Battle of the Atlantic before its industrial might could fully mobilize. Faced with this grim reality, the decision to authorize Kaiser's innovative approach was driven not by confidence in untested technology, but by sheer necessity. The Richmond shipyard, a vast and previously empty stretch of mud flats nestled between the James River and land, was rapidly transformed. Between January and December of 1941, a state-of-the-art facility emerged that shocked even seasoned maritime engineers. Unlike the traditional shipyards characterized by massive gantry cranes and lengthy building ways, Richmond's layout bore little resemblance to the norm. Instead, it was designed akin to an automobile assembly plant, emphasizing rapid assembly and mass production. The yard was organized with open-plan areas dedicated to prefabrication, massive steel sections that could be produced off-site and quickly assembled later. Surrounding these were 7 parallel building ways, or assembly lines, where the prefabricated sections could be joined. Railroad tracks crisscrossed the entire complex, enabling the efficient transportation of enormous steel segments, some weighing as much as 150 tons, across the yard. Overhead cranes, strategically positioned every 100 feet, were capable of lifting entire ship sections, facilitating swift and flexible assembly. In May of 1941, John Riley, chief naval architect for Bethlehem Steel Corporation and a veteran of 3 decades in shipbuilding, toured the Richmond yard. His confidential inspection report offered a nuanced view, blending technical criticism with a grudging sense of admiration. Riley noted that Kaiser's design flagrantly defied every principle of efficient shipyard layout he had learned during his extensive career. He pointed out that the prefabrication areas seemed overly large, the crane capacity appeared excessively powerful, and the building ways were shorter than ideal. Nonetheless, Riley acknowledged that the entire facility was meticulously designed to fulfill its core purpose: rapid assembly of prefabricated ship sections, a revolutionary concept at the time. The arrival of workers marked the next phase in this dramatic transformation. Traditional shipyards primarily recruited from established maritime communities, where generations had mastered the craft of shipbuilding, places like the Atlantic coast, the Great Lakes, and the Gulf of Mexico. These workers brought with them a wealth of experience in rivet work, hull assembly, and seam welding, and their skills were deeply ingrained in the existing shipbuilding culture. However, as the new Richmond yard aimed to build ships at the transfer of skills from father to son, an enduring tradition that has shaped generations, has long served as a vital conduit for preserving specialized knowledge within families. It was this deep-rooted understanding and mastery that Kaiser, a pioneering industrialist, sought to harness and expand through a bold advertising campaign across newspapers throughout the United States of America. His advertisements boldly offered wages that were 20% higher than the prevailing standard rates in the industry, along with a promise to provide comprehensive training to any individual willing to commit their efforts to work. This approach was aimed at attracting a broad, eager workforce, regardless of prior experience, by emphasizing opportunity and immediate earning potential. The first groups of workers, drawn by these enticing prospects, arrived in Richmond, Virginia, during the month of August in the year of 1941. Their arrival marked the beginning of a revolutionary shift in shipbuilding practices, rooted in the innovative simplification of complex tasks into smaller, repeatable operations. This concept was borrowed directly from the principles of assembly line manufacturing, which emphasized efficiency through the division of labor and specialization. The results of this approach proved to be not just effective but devastatingly so. By the time autumn arrived, in October of the same year, Kaiser's shipyard in Richmond had already employed over 10,000 workers. Notably, fewer than 200 of these workers possessed any prior maritime experience, underscoring the rapid learning curve and the effectiveness of the training program. In traditional shipbuilding, welders typically spent 4 years as apprentices, acquiring a broad and comprehensive set of skills through extensive hands-on experience. They learned to perform a wide array of welding techniques, mastering the craft through years of practice. In contrast, Kaiser's instructional methods focused on teaching specific, targeted skills tailored to particular tasks, often within a span of approximately 2 weeks. Workers were not expected to master the art of welding every part of a ship but instead concentrated on precise, repetitive tasks such as welding vertical seams on bulkheads, horizontal deck plates, or curved hull sections. These tasks, performed repeatedly, formed the core of their work, allowing workers to become highly proficient in their designated area without the need for a broad skill set. As the months progressed into late 1941 and early 1942, an unexpected, yet revolutionary development began to unfold. The construction time required for Liberty ships, which were vital to the war effort, started to decline sharply. The very first Liberty ship built in this manner took an astonishing 197 days from start to completion and delivery. The second ship, benefiting from improved processes and experience, was built in just 169 days. As the process continued to optimize, the fifth Liberty ship was completed in only 128 days, and by the 10th vessel, the construction time had plummeted to 97 days. By the spring of 1942, the average time to build a Liberty ship in Richmond had decreased further, reaching an impressive 70 days. The traditional shipyards, adhering to more conventional methods and skilled labor, looked on with growing concern and alarm as this untrained, yet rapidly learning workforce achieved production speeds that rivaled, and in some cases surpassed, their own highly skilled crews. The key to this unprecedented productivity lay in Kaiser's innovative prefabrication strategy, which had once been dismissed by traditional shipbuilders as impractical or inefficient. Instead of constructing ships sequentially, from keel to deck, Kaiser's yards fabricated entire sections simultaneously across various parts of the facility. This method allowed multiple components to be built in parallel, dramatically reducing overall construction time. While one team of workers assembled a bow section in the prefabrication area, other teams simultaneously worked on building the stern sections, deck houses, engine rooms, and bulkheads, all in parallel. When these sections were completed, massive cranes, capable of lifting enormous loads, transported them onto the ship's building ways, where welding crews assembled the parts into a cohesive whole. Albert Wooding, serving as a production supervisor at Richmond Yard No. 2, vividly explained the remarkable efficiency of this approach in an interview published in Fortune magazine in 1943. He pointed out that in traditional shipbuilding, the process was strictly sequential. The engine could not be installed until the engine room was fully constructed, and the engine room itself could not be built until the hull was complete. Consequently, everything had to happen step by step, often leading to extended construction timelines. Kaiser's method, by contrast, employed the principle of parallel production, allowing multiple tasks to be carried out simultaneously. For example, while one team of workers welded hull plates, another team was assembling the engine in a separate area. Once both components were ready, the engine was simply dropped into the already completed engine room, and the final welds were made. This innovative approach drastically reduced the time required for tasks that traditionally would have taken weeks to complete. Tasks that previously demanded weeks of painstaking labor could now be accomplished within hours. The statistical data underscoring this new manufacturing efficiency was staggering and challenged the very notions held by traditional shipbuilding establishments. The goal was to orchestrate the entire assembly process within a single span of just 8 hours, an almost unbelievable feat that would drastically redefine the traditional standards of shipbuilding efficiency. What made this approach even more startling to seasoned maritime authorities was the casual disregard for centuries-old craftsmanship and time-honored building methods that had long been considered the backbone of naval construction. For generations, ships had been meticulously built according to detailed, carefully prepared plans, with every component and dimension precisely specified to ensure durability, safety, and seaworthiness. These plans served as blueprints, guiding skilled craftsmen through a complex process that demanded exactitude and attention to detail. In stark contrast, Kaiser introduced a radically simplified approach, relying on crude drawings that outlined only the essential dimensions necessary to get the ships underway. The finer details and nuanced judgments that traditional builders relied upon were deliberately left to the discretion of the workers on the shop floor. This departure from convention was viewed by traditional maritime circles as reckless and potentially dangerous, risking structural integrity and design fidelity. Kaiser, however, defended his methods by emphasizing their inherent flexibility, asserting that such an approach allowed for faster, more adaptable construction without sacrificing the core functionality of the ships. At first, even high-ranking officials such as Vice Admiral Howard Vickery, who served as vice chairman of the Maritime Commission and had a long career in the Navy, pushed back against Kaiser's looser specifications. His initial skepticism was rooted in a deep-seated belief that maritime construction demanded the utmost precision, and that sacrificing detailed plans could compromise safety and performance. Yet, as the results began to emerge, even Vickery's opposition slowly waned. Minutes from the commission meetings record his eventual shift from staunch critic to enthusiastic supporter, a transformation driven by the undeniable evidence of what results could achieve when speed and efficiency took precedence over traditional meticulousness. By January of 1942, I personally opposed Kaiser's request to further relax drawing standards, emphasizing that ships were vastly different from automobiles, where tolerances could often be more forgiving. Maritime construction, I contended, required exacting precision to ensure safety at sea. Nevertheless, by March, Kaiser's shipyards were outpacing traditional contractors by an astonishing 40% in daily output. The rapid pace of production was relentless, and it became evident that the simplified methods, though lacking in aesthetic beauty, produced ships that were sufficiently robust and functional to meet wartime needs. In fact, these ships, while perhaps not elegant, were perfectly adequate for their intended role. The key advantage was that ships built swiftly and efficiently could deliver more cargo in less time than their more meticulously crafted counterparts, which remained under construction for longer periods. As the spring and summer of 1942 unfolded, the accelerated production rates fostered a spirited rivalry among Kaiser's 7 shipyards, strategically located across California, Oregon, and Washington. This competition was not merely internal, it became a spectacle for the wider public and industry observers. Kaiser's son, Edgar Kaiser, who held the position of vice president and general manager, was responsible for coordinating operations across all the shipyards, with particular attention paid to the 3 facilities in the Pacific Northwest. Edgar managed the Oregon Shipbuilding Corporation located in Portland, while Clay Bedford oversaw the operations at the Richmond yards in California. Both men were driven by ambition and a desire to outperform one another, sparking an informal contest to see which yard could produce ships at the fastest possible rate. The race between the Richmond and Portland yards captivated the public and media alike, with newspapers reporting on their progress much like sports scores, providing updates and highlighting record-breaking achievements. Throughout the fall of 1942, the competition reached new heights, with record times repeatedly shattered. Notably, in September of that year, the Oregon Yard managed to complete the construction of the Liberty ship Joseph Neal in a mere 10 days, a feat that had previously seemed impossible. The extraordinary speed at which the Oregon Yard was able to complete ships drew significant attention and admiration. Vice Admiral Vickery, however, eventually decided to put an end to these speed contests, deeming them mere stunt demonstrations that detracted from the more important goal of steady, reliable production. Nonetheless, the displays of speed had already achieved their purpose. They instilled in workers across all 7 Kaiser yards a new mindset. That extraordinary speed was not just a goal but an expectation. The true test of this newfound momentum came in November of 1942. Vice Admiral Land, during a routine visit to the Richmond yard for an inspection, made an offhand remark to some journalists that was overheard by Clay Bedford. The Admiral noted that while Liberty ship construction had seen significant improvements, the current speed record still paled in comparison to what had been achieved in other industries through mass production techniques. Bedford, hearing this comment, saw a challenge rather than a mere observation. He proposed to Vice Admiral Land that the Richmond Yard's No. 2 facility attempt to build a complete Liberty ship from the laying of the keel to launching in less than 10 days. A plan to cut the existing record in half in a manner that carefully ensured the continuity of regular production schedules. The project meticulously planned its operations to avoid any disruptions. The decision was made to select the 47th hull for construction at Yard No. 2, a choice driven by the desire to set a new record in shipbuilding speed. This vessel was to be christened SS Robert E. Peary, named in honor of the renowned Arctic explorer whose daring expeditions had captured the imagination of many. The selection of this particular hull was not arbitrary but part of a strategic effort to push the boundaries of maritime construction and efficiency. Commencing on the early hours of Sunday, November 8, precisely 1 minute after midnight, a monumental effort would unfold involving over 1,000 workers. These workers, organized into precisely coordinated shifts, were tasked with executing an unprecedented feat in the history of maritime engineering. The scale of this operation was immense, requiring flawless synchronization across multiple teams working in tandem to accelerate the building process while maintaining the highest standards of quality and safety. The prefabrication approach employed in this project reached its zenith during the construction of the ship's pier. All major components of the vessel had been manufactured, inspected, and staged well in advance of the actual assembly process. This meticulous preparation meant that the keel, the backbone of the ship, was the first piece to touch the building ways, not as a trigger for construction but as the culmination of a carefully orchestrated sequence of prefabrication steps. The bow section, consisting of over 50 individual steel pieces, had been fully welded together and equipped beforehand with essential hardware such as anchors, chain lockers, and the forward crew quarters, ready to be integrated into the main structure. Similarly, the stern section was fully assembled, featuring a completed steering gear system, the propeller shaft, and the aft crew spaces, all prepared and tested in advance. The cargo holds, 4 in total, were massive rectangular steel structures designed to carry the ship's load efficiently, and each was pre-constructed and weighted appropriately to facilitate swift installation. The engine, a formidable triple-expansion steam power plant weighing approximately 140 tons, was constructed by Joshua Hendy Iron Works located in Sunnyvale. It had been mounted on its foundation and subjected to rigorous testing before leaving the factory, ensuring readiness for installation. While traditional shipyards typically build ships from the keel up over several months, assembling each component piece by piece in a linear fashion, Kaiser's yards employed a radically different approach. They assembled nearly complete ships from prefabricated sections within a matter of days. Remarkably, by the 4th day of construction, the hull was fully assembled, the engine had been installed, deckhouses positioned, cargo holds secured, and steering gear mounted, all within an astonishing span of just 4 days. On Thursday, the 12th of November, precisely at 3:30 in the afternoon, just 4 days, 15 hours, and 29 minutes after the keel first touched the building way, the SS Robert E. Peary was ready to be launched. It slid smoothly down the launching rails into the waters of San Francisco Bay, marking a historic milestone in shipbuilding history. The vessel was completed and delivered for service on the 15th of November, setting an additional record by moving from the laying of the keel to full operational readiness in only 7 days, 14 hours, and 32 minutes. The event drew a considerable crowd of witnesses, including maritime officials, military officers, owners of competing shipyards, and journalists from across the United States. Many of these observers had arrived with skepticism, expecting either failure or to see a vessel that appeared complete but lacked operational functionality. Instead, they witnessed a fully operational ship, requiring only minimal fitting and finishing touches before it could enter active service, an extraordinary demonstration of speed and efficiency. Vice Admiral Land, present at the launch, delivered brief remarks that were captured by newsreel cameras. His words reflected both surprise and acknowledgement from the maritime establishment that the traditional methods of shipbuilding had been fundamentally challenged. He remarked, "6 months ago, I would have called this impossible." This statement encapsulated the magnitude of the breakthrough, highlighting how revolutionary the new approach was perceived to be. The centuries-old wisdom of shipbuilding, accumulated over more than 3,000 years, held that creating a properly constructed vessel would take many months, often exceeding several years. Conventional methods dictated that building a ship from keel to deck in less than half a year was unthinkable. However, Henry Kaiser's innovative techniques had rendered this long-held belief obsolete. His methods demonstrated that with prefabrication, precise coordination, and modern assembly techniques, ships could be built at a fraction of the traditional time frame. As a result of this success, the United States Maritime Commission announced that all contracted shipyards would be required to adopt these accelerated construction methods. This decision represented a significant shift in maritime manufacturing policies, driven by the undeniable proof that such rapid construction was not only possible but also practical. The immediate psychological impact on established shipbuilders was profound and unfolding rapidly. Many of the traditional yards, which had previously dismissed Kaiser's innovations as imper in December of 1942, a pivotal moment unfolded at Kaiser's shipyard in Richmond, marking a significant turning point in the history of American maritime manufacturing. During this period, a confidential report was drafted and submitted to the company's board of directors, revealing a profound and unsettling erosion of traditional beliefs and approaches concerning shipbuilding. The report highlighted how Kaiser had achieved what many in the industry considered nearly impossible. He had fundamentally broken free from entrenched limitations that had long constrained ship construction. Rather than viewing shipbuilding as an artisanal craft rooted in generations of specialized knowledge, Kaiser approached it as a straightforward manufacturing challenge. This shift in perspective was revolutionary. He sought to simplify processes where others aimed for perfection, opting for standardization over customization, and replaced the reliance on age-old expertise with mass training of unskilled or semi-skilled labor. This was an audacious departure from the norm, where previous shipyards cultivated deep, generational skill and meticulous craftsmanship. Kaiser's methods emphasized efficiency, rapid production, and the mobilization of a vast, largely untrained workforce. The impact of Kaiser's innovative approach was nothing short of extraordinary. Ships that traditionally took many months to build could now be constructed in a fraction of that time, at vastly reduced costs. Specifically, ships that previously required several hundred days to complete were now being produced in about one-tenth of that duration, at roughly two-thirds of the traditional expense. This revolution in shipbuilding was so profound that by early 1943, Kaiser's influence had begun to reshape the entire landscape of American maritime production. Across the nation, 18 shipyards adopted Kaiser's pioneering techniques, utilizing prefabrication and welding, methods that facilitated rapid assembly and minimized waste. The results were staggering. The average time to construct a Liberty ship plummeted from approximately 230 days to just 42 days by mid-1943. As a consequence, the United States was capable of launching 3 Liberty ships every single day, generating more tonnage than the German submarines could sink in any given period, effectively turning the tide of naval warfare and supply logistics. Yet, perhaps the most disruptive aspect of Kaiser's transformation was the nature of the workforce itself. The new shipyards employed tens of thousands of women, minorities, and untrained workers, individuals who, in many cases, had no prior experience in shipbuilding. Their central role in constructing these vessels directly challenged the centuries-old guild system that had historically governed maritime craftsmanship and reputation. During the peak of wartime production in 1944, Kaiser's 7 shipyards employed roughly 196,000 workers, a significant portion of whom, over 40,000, were women. This represented a remarkable shift, as women now made up approximately 27% of Richmond's workforce by mid-1944. The employment of African American workers was equally noteworthy. Tens of thousands of African Americans worked in skilled positions such as welding, fitting, crane operation, and even supervisory roles, an unusual level of workplace integration for the United States during the 1940s. This democratization of skilled labor at Kaiser's yards not only broke down racial and gender barriers but also extended implications well beyond wartime necessity. By demonstrating that large-scale, complex manufacturing could be successfully carried out by trained, diverse workers, without the need for multi-generational craft skills, Kaiser's shipyards challenged fundamental assumptions about labor, skill, and industrial organization that had persisted for centuries. The cultural and social impact of these changes was vividly demonstrated during Christmas of 1943. While traditional shipyards typically observed the holiday with only a day or two off, Kaiser's facilities maintained their rigorous production schedules. However, rather than simply demanding continued work, Kaiser's management organized Christmas celebrations that acknowledged and appreciated the sacrifices made by the workforce. At the Richmond yards, workers enjoyed a festive Christmas dinner served in the yard's cafeterias, featuring turkey, ham, and all the traditional accompaniments, provided free of charge to those working during the holiday. Local churches sent carolers to lift spirits, and the Richmond Municipal Band performed seasonal melodies. Perhaps most notably, Kaiser himself visited the yards, personally greeting workers, shaking hands, and expressing his gratitude for their dedicated service during such a critical period. By the middle of 1944, the combined efforts of Kaiser's 7 shipyards had resulted in the production of over 800 Liberty ships, an achievement that underscored the remarkable transformation of American industrial culture. This rapid, standardized, and inclusive approach had not only fueled wartime logistics but also redefined the possibilities of industrial manufacturing in the United States, paving the way for a new era where efficiency, innovation, and social progress worked hand in hand. Hips, a fundamental part of the human body, play a crucial role in our daily movements and overall mobility. They serve as the central junction where our pelvis connects to the upper legs, allowing us to walk, run, jump, and even maintain our posture with remarkable efficiency. These joints are not just simple hinges. They are complex structures composed of bones, muscles, ligaments, and tendons working in harmony to facilitate a wide range of motion. The hips are designed to bear weight and absorb shock, making them integral to our ability to perform countless activities from the mundane to the extraordinary. The influence of innovative approaches in the field of manufacturing and industrial production extended remarkably beyond the confines of individual factories or specific facilities. During a pivotal period of rapid industrial expansion, particularly in the United States, the scope and scale of shipbuilding efforts became a testament to the extraordinary capabilities of wartime innovation. At that time, 18 American shipyards, each a hub of intense activity and ingenuity, had collectively managed to produce a staggering total of 2,400 ships. These vessels were primarily Liberty ships, which were mass-produced cargo ships designed to meet the immense logistical demands of World War II. Their construction methods, especially the use of prefabrication and welding techniques, revolutionized maritime manufacturing. As the war progressed, the United States introduced an even larger and faster ship design called Victory ships. These vessels served as a vital supplement to the Liberty fleet, beginning production from the year 1944 onward. The Victory ships were built using the same revolutionary prefabrication and welding techniques, which allowed for quicker assembly and greater efficiency. This shift in design and production methodology underscored the innovative spirit driving American industry during this critical period. Between the years 1941 and 1945, the combined output of American shipbuilding efforts surpassed an extraordinary total of 5,500 vessels. In terms of cargo capacity, this represented approximately 53 million tons of shipping, a figure that remains impressive even by today's standards. To contemporary observers, the sheer magnitude of this industrial achievement was staggering. It demonstrated an unparalleled scale of production that underscored the United States' pivotal role in wartime logistics and supply chain management. One notable observer was Commander Joseph Kenworthy of the Royal Navy, who was assigned to the British Admiralty delegation stationed in Washington. His observations of American industrial output were marked by a mixture of admiration and a hint of envy. In the declassified reports he submitted to the British Admiral in the 1980s, Kenworthy detailed his impressions of the formidable American dominance in shipbuilding, an industrial prowess that seemed far beyond the capabilities of other nations at the time. At that moment, the United States was producing merchant ships at an astonishing rate, one that exceeded the combined capacity of all other nations in the world. For example, Kaiser shipyards alone was manufacturing more tonnage each month than the entire British shipbuilding industry could produce in the same period. These American ships, while often considered crude by the standards of traditional maritime craftsmanship, were nonetheless robust, seaworthy, and capable of carrying cargo across the oceans. They might not have been elegant or finely crafted, but they floated, reliably and in large numbers, and that was the primary goal. In stark contrast, the Royal Navy was renowned for its beautifully constructed warships, built through meticulous craftsmanship that often took years to complete. These vessels were the epitome of maritime elegance and tradition, crafted with attention to detail and high standards rooted in centuries of naval history. Yet, when the urgency of wartime logistics demanded rapid response, the Americans proved that ships built quickly and adequately could surpass the sheer numbers of the finest warships. The philosophy was simple. Adequate ships built in weeks, multiplied by thousands, could outperform perfection achieved in fewer vessels but over many years. Perhaps the most remarkable aspect of Kaiser's transformation during this period was not just the wartime production itself, but what transpired after the conflict ended. Conventional wisdom among analysts anticipated that the boom in shipbuilding would quickly collapse once the war concluded, resulting in mass unemployment and the abandonment of costly shipyards. This prediction turned out to be only partly true. Liberty ship production ceased in September of 1945, as planned, reflecting the end of wartime necessity. By the time December arrived, Kaiser's workforce had dramatically shrunk from a peak of 200,000 employees to fewer than 20,000. The Richmond shipyards, which had employed around 100,000 workers at the height of their activity, stood largely deserted by the spring of 1946. Despite this dramatic contraction in workforce and activity, the technological advancements and manufacturing techniques developed during the emergency did not fade away. Instead, they laid the groundwork for future maritime industries across the globe. The innovations pioneered during this intense period, such as prefabrication, welding procedures, and parallel assembly methods, became standard practices in shipbuilding worldwide. When Japan and South Korea embarked on rebuilding their maritime industries in the 1950s and 60s, they looked back to Kaiser's Liberty ship program as a blueprint for success. These nations adopted the shipbuilding industry had long been regarded as an area where rapid, large-scale construction was deemed inappropriate or even impossible, given its complexity and the traditional craftsmanship involved. However, within a mere 3 years, a remarkable transformation took place. A single individual managed to oversee the construction of more ships than had been built in the entire United States during the preceding 100 years. This achievement not only shattered existing perceptions about the capacity of American industry but also set the stage for a fundamental revolution in how ships would be designed and assembled around the globe for the rest of the 20th century. This individual was Henry Kaiser, whose innovative approach to shipbuilding, centered on modular construction, prefabrication, and welded assembly, became the gold standard worldwide. These methods, which Kaiser pioneered during the construction of the Liberty ships, have since become integral to modern shipbuilding practices. Today, whether one considers the massive container ships built in South Korea, the vast oil tankers constructed in Japan, or the luxurious cruise ships produced across Europe, all rely heavily on techniques derived from Kaiser's pioneering programs. His influence is woven into the very fabric of contemporary maritime construction, marking a transformative era in the industry. The enormity of Kaiser's accomplishments can be appreciated through the impressive statistics that illustrate both the scale of the wartime shipbuilding effort and its extraordinary efficiency. Between the years of 1941 and 1945, a total of 2,710 Liberty ships were produced across 18 American shipyards. At the height of production, this amounted to an astonishing average of approximately 1.8 ships completed every single day. In particular, Kaiser's own 7 shipyards alone contributed to the construction of 1,490 ships, accounting for roughly 27% of the entire American merchant fleet built under maritime commission contracts during the wartime period. The rapid pace of construction saw the time required to build each Liberty ship plummet dramatically. Initially, in 1941, the average duration from laying the keel to launching the vessel was about 230 days. By 1943, this figure had been reduced to just 42 days. The record for the fastest build belonged to the vessel named Robert E. Peary, which was completed in only 4 days and 15 hours from the keel laying to launch, a feat that exemplifies the revolutionary efficiency Kaiser's methods achieved. This rapid progress was largely driven by the workers gaining experience and becoming highly skilled at their specific tasks. In the beginning, constructing a Liberty ship demanded approximately 1,100,000 worker hours, but by 1943, this number had fallen to around 486,000 hours per vessel. Kaiser's most efficient yards, notably Richmond yards No. 2 and 3, pushed the limits even further by completing ships in as few as 350,000 worker hours. They achieved this through the use of intensive 3-shift, 24-hour work schedules and by maximizing the use of prefabricated components, enabling the ships to be assembled swiftly and efficiently. Cost-wise, the savings were equally impressive. The initial Liberty ships had a price tag of roughly $1.75 to $2 million each. However, by 1943, costs had decreased to approximately $1.8 million, despite the rising wages and increases in material costs. This decline in expense reflected not only economies of scale but also the cumulative effect of continuous improvements, streamlined processes, and a steep learning curve that Kaiser's teams had mastered. In terms of capacity, each Liberty ship displaced around 14,245 tons when fully loaded. These vessels could carry a cargo of roughly 10,800 tons, enabling them to transport an astonishing array of military and logistical supplies across the oceans. For instance, in a single voyage, a Liberty ship could carry over 2,800 jeeps, 440 tanks, or approximately 230 million rounds of ammunition, an incredible testament to their cargo-carrying capacity. Powered by triple expansion steam engines, which were deliberately chosen for their proven reliability and ease of manufacture, despite being somewhat old-fashioned, these ships could achieve speeds of around 11 knots. While not the fastest vessels afloat, these speeds were adequate for convoy operations, which required durable, dependable ships capable of maintaining steady progress despite the dangers of wartime navigation. Training workers to operate and assemble these ships was another area where Kaiser's innovations shone brightly. His dedicated training schools could prepare workers in specific tasks in as little as 2 weeks, a remarkably short period compared to traditional maritime apprenticeships. The fastest-trained spot welders, for example, became productive in just 10 days, demonstrating the effectiveness of specialization and repetitive task training. More complex roles, such as crane operators or ship fitters, typically required between 4 and 6 weeks of instruction. In stark contrast, traditional maritime apprenticeships often took 4 years to produce basic competency and up to 10 years to achieve master craftsman status. The key difference was that Kaiser's training emphasized specialization. Workers mastered specific, repeatable tasks to perform them hundreds of times, resulting in a highly efficient workforce capable of throughout the course of the war. The innovative construction methods employed in building the Liberty ships demonstrated their impressive effectiveness, even in the face of considerable skepticism regarding the rapid assembly techniques used. An astonishing total of approximately 2,700 Liberty ships were constructed over a relatively short period, a true testament to the industrial might and ingenuity of that era. Out of these, around 200 ships were lost due to enemy action, which translates to a loss rate of roughly 7.4%. When compared to the maritime loss rates seen in the pre-war period, this figure was quite favorable, highlighting the resilience and seaworthiness of these vessels. Despite initial doubts about the welded construction process, it ultimately proved capable of producing ships that could reliably perform at sea. Nevertheless, some ships did suffer structural failures attributable to welding defects, which prompted closer scrutiny and improvements in manufacturing techniques. A very small fraction of the fleet, specifically 3 Liberty ships, experienced catastrophic failures, breaking entirely in half due to brittle fracture issues. These incidents represented only about 0.11% of the total production, underscoring just how rare such failures were. Throughout the fleet, nearly 1,500 instances of significant brittle fractures were documented. However, complete and sudden breaks remained uncommon. Recognizing the seriousness of these problems, engineers and shipbuilders undertook comprehensive revisions of welding procedures and steel quality standards, which successfully eradicated the brittle fracture issue by the year 1944. The long-term durability of Liberty ships provided the ultimate validation of Kaiser's pioneering construction strategies. Originally designed as emergency vessels with an expected service life of approximately 5 years, many ships exceeded these expectations remarkably. Numerous Liberty ships remained operational for decades after the conclusion of the war, demonstrating their resilience and the robustness of their design. An illustrative example is the SS John W. Brown, launched in 1942, which, as of 2024, still functions as a museum ship moored in Baltimore, more than 82 years after its initial launch. Similarly, the SS Jeremiah O'Brien, also built in 1942, is preserved in San Francisco and participated in the commemoration of the 50th anniversary of D-Day in 1994. Remarkably, it managed to sail under its own power to Normandy during that event, demonstrating its enduring seaworthiness after more than 50 years of service. Another Liberty vessel, the SS Helles Liberty, now serves as a static museum ship in Greece, standing as a lasting reminder of the era. Post-war, the careers of Liberty ships extended far beyond their original intended lifespan. Of the roughly 2,500 ships that survived the conflicts, about 835 remained active in commercial service into the 1960s. Many of these ships were sold off to foreign shipping companies, where they continued to operate well into the 1970s, further testament to their durability and versatility. A notable example among the later ships is the SS Albert MBO, which holds the distinction of being the last Liberty ship built and delivered. It was completed on the 30th of October, 1945, shortly after the war's end. Unlike many of its counterparts that were scrapped, this vessel was repurposed, in 1964. It was sold for $65,557 and became the fish canning ship Star of Kodiak in 1965. Today, it remains in existence as the landlocked headquarters of Trident Seafoods in Kodiak, Alaska, an extraordinary achievement considering it is over 8 decades old. The Liberty ship program's influence extended well beyond the ships themselves, leaving a profound economic impact across various sectors of American industry. The enormous demand for steel to construct these vessels significantly stimulated steel production capacity, especially along the West Coast, where Kaiser established the Fontana Steel Mill specifically to supply his shipyards. Completed in 1942, 5 months ahead of schedule, the mill produced approximately 700,000 tons of steel annually, marking California's emergence as a major steel-producing region for the first time in its history. The production of magnesium, used for incendiary bombs, and aluminum, necessary for aircraft manufacturing, was also ramped up through Kaiser's dedicated plants, supporting the broader integrated war production effort. The employment ripple effect was dramatic, transforming communities across California, Oregon, and Washington. The city of Richmond, California, experienced a population explosion, growing from around 23,000 residents in 1940 to over 100,000 by 1943. Driven entirely by the surge in shipyard employment, Kaiser also built Vanport City in Oregon, which for a brief period became one of the largest and most dynamic urban centers in the region, a symbol of the wartime industrial boom. Was not an immutable truth but rather a flexible framework that could be reshaped and expanded when driven by urgent necessity and innovative thinking. His approach shattered long-held beliefs about the limits of American industrial output, revealing that with enough determination and strategic coordination, even seemingly insurmountable challenges could be overcome in remarkably short timeframes. At the heart of this remarkable industrial surge was a collective mindset shift among managers, engineers, and workers alike. The urgency of wartime production fostered a culture of adaptability and relentless problem-solving, breaking down traditional bureaucratic barriers that often slowed progress in peacetime industries. This rapid mobilization demonstrated that with the right organizational principles, such as parallel processing, simplified specifications, and swift, targeted training, massive-scale manufacturing could be achieved efficiently and effectively. The impact extended well beyond the production of ships. The technological innovations, especially in welding techniques refined under wartime pressures, quickly became standard practices in multiple sectors. These advancements revolutionized not only maritime construction but also influenced fields such as structural steel fabrication, petroleum refining equipment manufacturing, and the production of pressure vessels. Prefabrication methods pioneered during this period laid the groundwork for modern construction practices, influencing the design and assembly of housing, bridges, and industrial facilities across the country. Furthermore, the organizational principles established during this intense period of shipbuilding became fundamental concepts in operations management and industrial engineering education. The ideas of parallel production lines, streamlined specifications, and rapid workforce training formed the backbone of efficient manufacturing and project management systems that persist to this day. One of the most enduring legacies of the Liberty Ship program was its influence on social mobility and economic opportunity. The program provided thousands of young Americans, especially women and minorities, with unprecedented access to skills, training, and career advancement. These opportunities often remained accessible long after the war, shaping the lives and careers of many individuals and contributing to broader social change. The technological and organizational lessons learned during this period also demonstrated the importance of flexibility and rapid adaptation in the face of national crises. As Harvard Business School professor Michael Porter highlighted in a significant 25th anniversary study of American industrial competitiveness, the Liberty Ship program exemplifies how a nation can swiftly assemble and scale industrial capacity when necessary. Before the war, the United States had only a modest merchant shipbuilding industry. Within just 2 years, it had surpassed the combined tonnage of all other nations, proving that infrastructure, skills, and systems could be rapidly developed under proper leadership and strategic focus. This episode in history underscored that limitations often perceived as inherent are frequently organizational or conceptual barriers in disguise. When these barriers are dismantled through innovation and determined effort, the potential for industrial growth and technological advancement is virtually limitless. The dramatic transformation of American industry during the war era stands as a testament to how necessity can fuel extraordinary progress, reminding us that what may seem impossible under normal circumstances can become achievable when driven by clear purpose, focused organization, and a willingness to challenge convention. Throughout history, there have been instances where innovation shattered long-standing beliefs and challenged the very foundations upon which industries and societies were built. One such remarkable example is the story of the Liberty ships during World War II, a narrative that ultimately underscores a profound and enduring truth about human potential and the astonishing possibilities of industrial achievement. These ships, which played a vital role in securing victory for the Allies, were not merely important because of their function in wartime logistics, but because their rapid construction revealed something much deeper: the transformative power of rethinking assumptions and embracing revolutionary methods. The significance of the Liberty ships extends beyond their steel hulls and logistical utility. It lies in what their rapid assembly demonstrated about human capability. For centuries, complex manufacturing processes, like shipbuilding, had been viewed as highly specialized, time-consuming endeavors rooted in tradition and craftsmanship passed down through generations. However, during this period of urgent wartime need, ordinary workers, those without specialized backgrounds or extensive experience, were able to produce these vital vessels in a matter of weeks rather than years. This shift was made possible through the application of systematic, organized processes that replaced the conventional craft-based approach. When necessity and ingenuity converged, industries that had resisted change for hundreds of years suddenly found themselves capable of revolutionary transformation within just a few months. This dramatic turnaround was not merely about technological advancement, it was a testament to a broader truth about human potential. It demonstrated that given the right training and opportunity, ordinary people could achieve extraordinary results. Results that once seemed impossible within traditional frameworks. The success of such a large-scale effort in shipbuilding was a clear proof that innovation does not always require new inventions but often hinges on re-envisioning how work is organized, managed, and executed. One of the most insightful reflections on the strategic implications of this industrial achievement was offered by Admiral Chester Nimitz, who commanded the United States Pacific Fleet during the war. In his memoir published in 1960, he recounted how the rapid production of ships in American ports was instrumental in countering Japanese military strategies across thousands of miles of Pacific Ocean. These ships were built at a pace surpassing the rate at which the enemy could sink them, a feat that fundamentally altered the course of the conflict. Japan's military planners, confident in the strength of American industry, had assumed that their naval campaigns could succeed by sinking enough ships to cripple U.S. logistics. They believed that, eventually, American supply chains would collapse under the weight of their losses and that negotiation would become inevitable. Yet, this assumption failed to consider the ingenuity of individuals like Henry Kaiser, whose contributions transformed the entire industrial landscape. By the year 1944, the United States was replacing ships faster than the enemy was able to destroy them, effectively turning the tide of the war in the Pacific. The arithmetic of attrition, the balance between losses and replacements, fell heavily in favor of the side capable of rapid and sustained production. It became clear that victory was dictated not by valor on the battlefield alone, but by the capacity to mobilize industry at an unprecedented scale. The outcome was ultimately determined in the bustling shipyards of Richmond, Portland, and Baltimore, rather than solely on distant beaches of Eniwetok or Okinawa. Henry Kaiser's most significant achievement was not just the staggering number of ships, 1,490, built under his leadership, but the profound shift in industrial mindset he inspired. His work proved that traditional methods and beliefs could be questioned and that revolutionary improvements required revolutionary approaches. For example, the famous case of the Robert E. Peary, built in less than 5 days, stood as a concrete symbol that the established notion of craftsmanship and tradition did not necessarily reflect the truth about what was possible. It demonstrated that conventional wisdom was often limited and that innovation could be achieved through systematic reorganization, relentless efficiency, and a willingness to challenge the status quo. Initially, many in the maritime establishment dismissed Kaiser as an outsider, lacking the specialized knowledge that had underpinned shipbuilding for generations. However, as the war progressed and the results became undeniable, industry leaders and military strategists alike began studying and adopting his techniques. The methods pioneered out of wartime necessity gradually transitioned into peacetime standards, influencing manufacturing practices across numerous industries worldwide. The skills learned by young workers, welding, fitting, fabricating, became the foundation of post-war economic revival, empowering a generation of industrialists, engineers, and laborers to rebuild and modernize America's economy. This story ultimately reveals a fundamental principle. Profound transformation often begins with a demonstration, a tangible proof that conventional limits are merely barriers waiting to be challenged. The remarkable success of Henry Kaiser's approach illustrates that revolutionary progress frequently comes from those unencumbered by tradition, willing to question long-held assumptions, and capable of organizing human effort in ways that unlock hidden potential. It makes clear that human potential is much greater than what conventional expectations suggest, especially when systems are designed to foster innovation and when people are empowered to prove what they are truly capable of achieving. The workers who built those ships were not inherently superior by nature. That pivotal lesson, demonstrated vividly in the bustling shipyards of Richmond and firmly validated by the remarkable feat of producing a total of 2,710 ships, continues to resonate powerfully today. It remains profoundly relevant whenever industries confront challenges that conventional wisdom might dismiss as insurmountable or impossible to overcome. The story of the Liberty ships, although most of these vessels have long since been dismantled, either scrapped decades ago or resting silently on ocean floors, embodies a revolutionary spirit that persists in the very fabric of modern manufacturing and industrial practices. This spirit influences contemporary shipbuilding, in every factory that employs prefabrication techniques to expedite production, in every educational program designed to rapidly impart specific skills rather than gradually cultivating broad expertise, and in the mindset of managers who question whether the term impossible truly signifies an insurmountable barrier, or simply indicates that no one has yet discovered a way to surmount it. The enduring legacy of Henry Kaiser is not etched in steel alone but is embodied in a transformed understanding of human potential, an understanding that emphasizes what dedicated and innovative individuals can achieve when liberated from the confines of traditional methods and encouraged to pursue seemingly unachievable goals. Kaiser's journey began in December of 1940, when, with little more than a determined spirit and a willingness to learn, he signed his first contract, unaware of the complexities of shipbuilding. Just nearly 2 years later, in November of 1942, he witnessed the extraordinary launch of the Robert E. Peary, which had been constructed in less than 5 days, a feat that seemed impossible by conventional standards. And by September of 1945, the last of these Liberty ships was delivered, marking the culmination of an unprecedented industrial effort. Through these achievements, Kaiser demonstrated that fundamental technological and organizational revolutions do not emerge solely from small, incremental improvements. Rather, they arise from a radical reimagining of what is feasible within the realm of industry. The 2,710 Liberty ships produced in the span of just 4 years, between 1941 and 1945, served not only as vessels for carrying cargo across the vast oceans, but also as powerful symbols of human ingenuity. They stood as living proof that, when freed from the shackles of tradition and driven by urgent necessity, human beings can accomplish what once seemed impossible. In essence, these ships exemplify the extraordinary capacity of human creativity and determination to reshape the limits of reality and redefine what is achievable under the most challenging circumstances.